Hello and welcome to Regrow Tech India. I'm your host, Dryrun, bringing to you yet another episode on the Java Beginners Interview Series. So, in this episode, we are going to do something we have already actually done. We have done this program on the special number, or rather, the Krishnamurthy number we discussed. But we have done this using the while loops. Now, for today's episode, however, we'd like to check that out using the for loops. Now, when I say so, that really does not mean that we are not going to use the while loop at all. It is that we are going to use nested loops, which is a loop inside another one. Now, for breaking down the digits of a number, we will be still using the while loops. However, for the factorial part of the number, we will be using the for loops. And that's the reason why I'm making this entire episode on it. So let's go ahead and get started. Now, if you do not remember as to what a Krishnamurthy number, or rather a special number is, let's first discuss what that is. Now here it says, write a program to check whether a number is a Krishnamurthy number / a special number or not. A Krishnamurthy / special number is a number whose sum of factorials of its digits is equal to the original number. So basically what they want us to do is get the number 145, get the factorial of each number. So 1 factorial, 4 factorial, the 4 does not look like 4, I'm aware, and 5 factorial. Get the sum of that. And if this sum is equals to the original number 145, then the number will be termed as the special number. And I believe you already must have understood that 145 is the perfect example of a special number. So we'll go ahead and first write the code and then we'll get back to the dry run. Here we are on to Eclipse mode. Give me a second. Why? Oh, yes, my bad. Okay. So, first of all, we are going to take a number int n equals, we're going to stick to 145 for now. Then we want to break down the number. So we'll start off with a while loop while n is greater than 0. And we have already discussed that in order to get the digits of the number, it's always a good idea to use the while loops. Inside this, we need the last digit. So first it will give me 5, then it will give me 4, and then it will give me 1. So 5 is the, the number in the units place. Then you'll get 4, the number in the tens place, and then we'll get 1, the number in the hundreds place. And how will we get this? We will write int ld is equals to n mod 10. And we'll also need to update n in order to actually get the loop running. So n equals n divided by 10. We will write it right here and we will be happy about it. Next up, we will take this LD and we will find the factorial. So first let us take int f is equals to 1 so that we can use this f in order to calculate the factorial. And then we'll start a for loop for int I equals 1, I less than equals LD, because we want to know the factorial of LD, and then I plus plus. And inside this, we want to do F equals F times I. This will fetch us the factorial of LD. That is why the loop goes up till LD. After that happens, we got the factorial. Now we need to also get the sum of all the factorials, right? The factorial of 5, the factorial of 4, and the factorial of 1. So we need to actually initialize the sum variable outside the while loop also. So int sum equals to 0. Then we will go here and we will say sum equals sum plus f. Okay. And now we will have to check. We will check if the sum is equals to the original number. But since we are using the while loop on the original number n itself, its value will turn to 0 by the end of the while loop. That is why we are going to take another variable int n1 equals n, so that this also has 145. And we can use that n1 in order to check the condition here. So if sum equals n1, then in that case print special number else not a special number. And that's about it. So we'll go ahead and run this. 145 is a special number. Let us take some other number. Let's say 154. Let's see if that is a special number. And it is not a special number, right? Let me try another number. I think 1442. I'm not sure, but I think this is special. No, it is not. Okay. So this is basically the program. We have already discussed the Dryrun in the previous, Krishnamurthy number program that we have already done. However, I'd like to do the Dryrun for this one only up till sum, because after that there will be a simple if condition. But let me copy that entire thing. Okie dokie, let's get to the whiteboard in order to check this out. So why does everything look so big? Okay, we'll see. Yeah, because I have written it so big. What happened? Oh, I did not copy it, did I? Now? Oh, thank God. Let me just decrease the size because we will kind of want to have a little space to write. Okay. By the way, we will be taking 145. I should have changed this before, but we are good. So we have variable n and we said n has 145. Okay, we can live with that. Int n1 is equals to n. So n has 145, n1 also will have 145. Next, sum is equals to 0. So sum is 0. Next, while n is greater than 0. So right now n is 145, it is greater than 0. It will go inside and then we will have LD. LD is supposed to be n mod 10. So 145 mod 10, we'll be left with 5. N is equals to n divided by 10. So 145, it will divide with 10 and it will give 14 as a result. Next, we have int f is equals to 1. So let's take f as 1. And then the for loop will go from 1 till LD. LD is 5. So there is an I loop that is supposed to go 1, 2, 3, 4 and 5. Okay, I'm not going to do the entire thing. For that, I will be putting down the link for you for the factorial program where we have done the Dryrun. You can check that out, right? If I do this Dryrun also, it will become very, very difficult for you to understand everything. So this for loop will just go from 1 to 5 because right now LD is 5. And it will do 1 multiplied by 2. So 1 multiplied by 2, it will be 2. 2 multiplied by 3, 2 3s are 6. 3 multiplied by 4, 6 4s are 24. And then 24 multiplied by 5 is 120. Okay. So f is supposed to have 120 after the first loop is done. Now here in the next line, once this loop is completed, in the next line, sum is equals to sum plus f is supposed to happen. So sum was 0, now it will become 120. Next time, the loop for the while loop has actually completed. So it will go back and it will check the n. N is greater than 0. Right now, n is 14. It is greater than 0. So it will go inside, it will get the LD. So LD is supposed to be right now 4. Because 14 divided by 10, the remainder is supposed to be 4. Okay. After that, what we will have is that n is equals to n divided by 10. So 14 will become 1. And again, the loop will run for f. Again, f will become 1. And then the I loop will run from 1 till whatever is the LD. LD has 4. Let me decrease the size. LD has 4. So the loop of for I will go from 1, 2, 3, 4. 1 multiplied by 1 is 1. 1 multiplied by 2 is 2. 2 multiplied by 3 is 6. 6 multiplied by 4 is 24. So by the end of this, f is supposed to have 24. Right? The for loop will be over and we will have sum is equals to sum plus f. So sum right now was 120. 120 plus 24 will fetch you 144. That will be your sum. Again, it reached the end of the while loop. It will go back and it will check while n is greater than 0. Right now, n is 1. It is greater than 0. Therefore, LD will happen. 1 divided by 10, the remainder will be 1. It will go inside the loop for I, and the value will just be 1 because the factorial of 1 is 1. So again, sum is equals to sum plus f. F में 1 है, 144 plus 1, sum plus f, right? So sum is 144, 144 plus 1 is 145, right? That is all. And again, it will go and check the condition while n is greater than 0. ये तो 0 हो गया होगा because n is equals to n divided by 10. So it must have already become 0, right? Next up, that means the condition will become false and it will stop the loop. We have already 145 in the sum. Next, it will check the if condition that we have. Sum is equals to n1. Sum has 145, n1 also has 145. Therefore, it's a special number. And that's basically all. I hope you have understood this program. I will be putting down the link for the Krishnamurty number using just the while loops, and the caption, the link for factorial numbers in the for loop, so that you can actually refer to that in order to get the complete dry run. Now, if you like the video, hit that like button and subscribe. Have a great day ahead. Bye-bye.